You might be wondering, is it possible to make an LED not on or off, but rather somewhere in the middle range? Can I dim an LED? And the answer is yes. And we're going to talk about some important understanding that comes before you get to the point where you can dim an LED, and then you'll really actually know what's happening when you do that. I want to start by saying, well, we've actually built sort of a quadrant, and we have actually already studied 3/4 of the quadrant, and we've left out the last quarter. So I'm going to draw this box and label the top the direction of electricity or information, and the left I'll label voltage, 0 or 5, and 0 through 5 volts. So if you want to find out about a voltage in the world that is either 0 or 5, and that's coming into the Arduino, this command is digitalRead. digitalRead is going to return an answer to you that is either high or low. And we know that high is the same thing as the number 1 in software, and low is the same thing as the number 0 in software. So to some extent, 5 volts is the equivalent of the number 1, and 0 volts is the equivalent of the number 0. If you want to push either 5 or 0 volts out, you use a command called digitalWrite. digitalWrite uses the same two arguments. It can either be high or low. There's nothing in the middle. It's binary. It's one of those two states. If you want to read a voltage coming into the Arduino that is part of a continuous range that's neither 0 volts nor 5, but more like 2.5 volts or 3.7 volts or something like that, let's say you want to read the position of a potentiometer, the command we used is analogRead. And the possible values for analogRead, the lowest value of analogRead was the number 0. And the highest, I'll do an arrow instead of a comma, the highest possible value of analogRead was 1023. And you would have seen that observationally if you had done the simple sketch where we first plug in the potentiometer and then start turning it back and forth and just looking at the values coming into the Arduino. You'll see the highest one is 1023. That does not mean 1023 volts, though. That actually means 5 volts. That number maps to that, and 0, the number 0 in analogRead, means 0 volts. So there is the one quadrant we haven't talked about, and if you use your powers of deduction, I bet you can figure out what this command is. Once you understand this system of the way we program the Arduino, it's very internally coherent. So this command in here is analogWrite. And the range for analogWrite is actually different than the range for analogRead. So that is a point of confusion, and it's something you're just going to have to remember. The range of analogWrite, the lowest analogWrite value is 0, so that's the same, but the highest is actually 255. In other words, if you try to do an analogWrite of 256 or something like that, anything higher than that or anything lower than 0, you'll get some weird behavior. You won't break the Arduino, but you'll get weird behavior. But it's an important and interesting thing to talk about. How does the Arduino actually do this analogWrite thing? How does the Arduino put out a voltage that is neither 0 nor 5? So it turns out that it can't, and it uses a trick because it can't actually really do that. So I'm going to draw a simple graph here where time is flowing to the right and voltage is over there on the left. 0 volts at the bottom, 5 volts at the top. The Arduino Uno that you have is a 5 volt device, so when it's on, it's at 5. There's different Arduinos that are, say for instance, a 3.3 volt Arduino. When that's on, the maximum would be 3.3, but ours is a 5, so we're going to stick with that standard. Let's say you wanted to send out a voltage that is neither 0 nor 5, but you're not able to do it. Sorry, because of the frozen video. One moment and I'll be back. I'll keep talking though. Let's say you want to send out a voltage that is neither 0 nor 5. all you can do is turn it on and off. And if you want it to be off, have the equivalent of a 50% voltage. So what I would say is, like, you want an equivalent, oops, of that little blue line there. Then here's how you do it. You turn the power on to 5, and then you turn the power off, and then you turn the power on, and then you turn the power off. And you do this very quickly. In the case of the Arduino Uno, you do this about 400 or 500 times a second, turning the power on or off on whatever that specified pin is. And if it's on half the time and off half the time, it will have the equivalent. It will be sort of equal to 50% voltage, which in this case is 2.5 volts. So that's if you want something to be half brightness. Well, what if you want something to be quarter brightness? Well, we just draw another graph, same idea. We're going to leave it on for a shorter amount of time and off for a longer. On for short, off for long. Something more like this. I'm not doing a fantastic job of representing it with my widths, but you get the idea. Now that would be, because it's spending most of its time off and only some of its time on, this would be more like this dotted line equivalent. So if this is about 25% on, then it's like, I don't know, well, I guess 1/4 of 5, which is 5/4, oops, 5/4 of a volt, which would be 1.25 volts. So the Arduino can't actually send out a voltage that is 1.25 volts. The best it can do is quickly turn power on and off and on and off and on and off to a pin, using this trick of varying how long the power is on versus off. It can simulate different output voltages. Now, if you want it to output this voltage up here, what you would do is the command analogWrite, whatever your pin is, I'll just go to a new line, comma, and what is halfway? Well, let's look at the value. If the minimum value is 0 and the maximum is 255, halfway is about 128. So you'd say analogWrite pin, whatever your pin number is, so think of the number 3 or something, and then the number 128. That would produce this behavior on that pin, on pin 3. If you wanted to do this, you want it to be 25% on, you want it to be about 1/4 of 255 is about, we'll call it 64. So 64 will be 1/4 brightness. Now, there's a name for this thing, this trick in electronics of varying the amount of time something is on or off. If you think of these things as pulses, and sure, they look like pulses, then you might understand why it's called pulse width modulation. But what do we mean by width? Well, what we mean is actually the width in time of that line on the graph. So when we say width in here, it's like sort of width in scare quotes because it's referring to the amount of time the thing is on or off. So pulse width modulation, abbreviated PWM, this is the engineering speak term for what this trick the Arduino is doing. Now, this is not available on all of your pins. It's crucially not available on any of the analog input pins. You might be thinking, oh, analog in, analog out. So if I do analog read on pins A0 through A5, maybe I could do analog write on those pins. No, different pins altogether. Take a look at your Arduino. Notice, get a little bit closer. Notice this funny little notation here. It says PWM and that squiggly, which is a tilde. That is pulse width modulation. And pulse width modulation is available only on the pins that have a tilde marked, namely on the Arduino Uno, 3, 5, 6, 9, 10, and 11. Those are the only pins you can actually do the analogWrite command on. If you try to do an analogWrite pin, oh gosh, all the cameras are dropping out. If you try to do an analogWrite on a different pin, it will not do anything. I'll just come back to me here. If you try to do an analogWrite on pin whatever 12, it'll just substitute it with a digitalWrite. So it'll either turn 12 on or off depending on what your analogWrite value is. So now that you know that, you can vary the brightness of an LED, you can vary the speed of a motor, you can vary all sorts of things and get actual continuous variation as an output, not only as an input.